All right, so in this video, we're going to talk about solving absolute value equations and inequalities. So let's start off with this example. So we have absolute value of 4y plus 12 is equal to negative 6y plus 4. All right, since we have the absolute value equation isolated on one side of the equation and everything else on the other side of the equation, we can go ahead and create our two cases. So our first case is going to be 4y plus 12 is equal to negative 6y plus 4. And our second case, case 2, is going to be 4y plus 12 is equal to the negative of the right-hand side. So negative 6y plus 4. And let's begin by solving case 1. So let's add 6y to both sides. And that gives you 10y plus 12 is equal to 4. Subtract 12 from each side. You get 10y is equal to negative 8. And then to solve for y, we just divide both sides by 10. And we get y is equal to negative 4 over 5. And so this is one potential solution to our absolute value equation. All right, so next we have case 2. So 4y plus 12. And let's go ahead and distribute this negative. So this becomes 6y minus 4. Subtract 6y from both sides. And we get negative 2y plus 12 is equal to negative 4. Let me fix that just a bit. Subtract 12 from both sides, and we get negative 2y is equal to negative 16. And finally, to solve for y, just divide both sides by negative 2. And we get y is equal to positive 8. So this is another potential solution to our absolute value equation. So to determine which values of y are solutions, we need to plug them back into our absolute value equation. So I'll write it again here. It's absolute value of 4y plus 12 is equal to negative 6y plus 4. So let's start by plugging in negative 4/5 for y. So you have the absolute value of 4 times negative 4/5 plus 12 is equal to negative 6 times negative 4/5 plus 4. Four times negative 4, that's 16. So absolute value of negative 16 over 5. And then we need to have a common denominator. So we multiply 12 by 5 and put it over 5. So this is plus 60 over 5, because 60 divided by 5 is 12. And then this is equal to negative 6 times negative 4 is positive 24 over 5. And then this 4 will become 20 over 5. So now we have negative 16 plus 60, that's positive 44. So 44 over 5 is equal to 24 plus 20, that's 44 over 5. And the absolute value of 44 over 5 is just 44 over 5. Here. So negative 4/5 is a solution to our absolute value equation. And now let's check if 8 is a solution for us. So we have absolute value of 4 times 8 plus 12 is equal to negative 6 times 8 plus 4. So we have the absolute value. 8 times 4 is 32, plus 12 is 44. Negative 6 times 8 is negative 48. Negative 48 plus 4 is negative 44. Absolute value of 44 is 44. So here we have 44 equals negative 44. That is not a true statement. So y equals 8 is what we would call an extraneous solution. So you arrive in case 2 at y equals 8, but it does not satisfy our absolute value equation. So we're not going to include it in the solution set. So our solution set for our absolute value equation is the set containing the number negative 4/5. Okay, so let's try another problem. If I can find it. Okay, so we have 2 times the absolute value of 7 minus 3y minus 6 is equal to negative 14. So we need to get the absolute value expression all by itself. So let's start by adding 6 to both sides. That gives us 2 times the absolute value of 7 minus 3y equals negative 14 plus 6 is negative 8. Our absolute value expression is still not all by itself, so let's divide both sides by 2. The absolute value of 7 minus 3y is equal to negative 4. So here we can see that we have the absolute value of something is equal to a negative number. And absolute values is the distance from 0 on a number line. So it can never be negative. Okay? So this means that our solution to this equation is the empty set. Oh, no 0 in there. Just curly braces with nothing inside. All right, let's do an inequality problem. So we have the absolute value of 2x minus 1 is less than 5 plus 1/2 x. So here we can split our inequality into 2 separate cases. So our first case is just going to be 2x minus 1 is less than 5 plus 1/2 x. So let's start by adding 1 to both sides. We get 2x is less than 6 plus 1/2 x. And now we can subtract this 1/2 x from both sides. 2 minus 1/2 is 3/2, or 1.5. So we get 3/2 x is less than 6. And to solve for x, we can multiply both sides of our inequality by the reciprocal of 3/2. And the reciprocal of 3/2 is 2/3. So we'll multiply by 2/3 on both sides. Those cancel. So now we have x is less than 6 times 2 is 12, divided by 3 is 4. So we have x is less than 4. In our second case, what we do is we still have our 2x minus 1, but we flip the inequality. So 2x minus 1 is greater than, and then the negative part, or the negative version of the right-hand side of the inequality. So negative 5 plus 1/2 x. That's supposed to be a parenthesis. I'll emphasize that. So here we have 2x minus 1 is greater than negative 5 minus 1/2 x. So let's add 1 to both sides. And we get 2x is greater than negative 4 minus 1/2 x. And now we can add 1/2 x to both sides. So 2 plus 1/2 is 5 over 2. So 5/2 x is greater than negative 4. And now to solve for x, we just multiply both sides of the inequality by the reciprocal. So we have x is greater than negative 8 over 5. So here we have to still check to see if our inequalities are true. So we have to test them out. So here, this inequality says for all values of x less than 4. So I'm going to pick 2 and see if our inequality yields a true statement. So remember, our inequality is 2x, absolute value of 2x minus 1 is less than 5 plus 1/2 x. So we have the absolute value of 2 times 2 minus 1 is less than 5 plus 1/2 times 2. 2 times 2 is 4, minus 1 is 3, so we have the absolute value of 3 is less than 5 plus 2 times 1/2 is 1, so 6. 3 is greater than 6, that's true. All right, now we have to test it with a number that's greater than negative 8/5. I'm going to choose negative 1. So we have 2 times negative 1 minus 1 less than 5 plus 1/2 times negative 1. So here, 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So we have the absolute value of negative 3 is less than 5 1/2 times negative 1 is just negative 1/2. So we have 3 is less than 4.5 or 9 over 4. And that is also true. So here our solution. We write our solution in set builder notation. So it's the values of x such that x is less than 4 or x is greater than negative 8/5. So on a number line, say we have 0 here, negative 1, negative 2, and we'll just say 4 is up here. So negative 8/5 is going to be right around here. So I'm going to draw an open circle because its x is greater than. And I'm going to draw an open circle at 4, 2. Here, I'll redraw this. And it's everything x is greater than negative 8/5 and x is less than positive 4. So it's all these values in between here that are solutions to our inequality.